Okay, guys, let's see. So now we'll do this example, okay, with the scale diagram method. Okay, so for example, you've got a boat and there's one boat that's being pulled slightly upwards to 7 newtons and there's one boat that's being pulled slightly downwards to 10 newtons, right? Okay. Now, how do you like solve this question? The problem is you cannot use Pythagoras over here. Why? If it were, a 90-degree angle, then you could use Pythagoras, but you cannot use Pythagoras over here. Pythagoras, I'll write that down. Pythagoras is only for right angles, right? We don't have a right angle over here between these, right? For example, if you were to take this and if you were to take this and you were to join them head to tail, do you see that when you join the tail with the head, it is not a right triangle, right? This is not forming a right triangle. So that's why you cannot use, 7 square plus 10 square to find out the resultant force. Okay. Now I do know that the resultant force is somewhere in between, right? It's probably more towards the 10 Newton side because the 10 Newton is pushing stronger than the 7 Newton, right? Okay. Now, first of all, you can do this with the Pythagoras, but you can do it with the scale diagram method, or you can also do it with the parallelogram method. Now, what is the parallelogram method? I'll show that in just a bit. So again, the rule is basically the same. You first of all assign, let's say, 1 centimeter to 1 Newton. Okay, up to you however long you want it to be. And then first of all, assign 1 centimeter to 1 Newton. You could do it whatever you want, right? You can also say that 2 centimeters show 1 Newton. That's up to you. You can do that as well. Okay. Then number two is draw uh both forces attached by tails. Okay. In this example, you don't join them head to tail. So you take this, okay, and you take this and you draw it as it is. You actually join the tails together. Okay. Now, what happens is when you join the tails together, first, in fact, let's draw it out. So let's say 7 Newton line, 7 centimeter line. So 1, 2, 3, 4, that's going to be pretty long. So 0, 1, 2, 3, 4, 6. So this is a 7 Newton line. And if I were to draw a 10 Newton line, so 10 Newton line is going to be 10 centimeters. So that must mean, oh, it's going to be pretty long. That's why it's easier to take a smaller scale, but let's just do it like this for the moment. Okay, so this is going to be 10 centimeters. Okay, so I've drawn two lines, right? This is the 7 Newton line, and this is the 10 Newton line. Now, what do I do next? Now, what you do is you just take these values, okay? You take the 7 Newton force, okay? And you draw a parallel force, okay? An exactly parallel force with the same length on the other side, on the other end. Okay, so that means, yeah, I can just duplicate it for now. I can duplicate it and I can draw it over here. Okay, so this is not 7 Newton at the moment. I've drawn it to be 7 centimeter
It's
and 7. Huh.
so to make it like perfectly parallel, then you just like
Yes.
do the other corresponding like so
Huh.
so the difference between the original angle and 180.
You can do that, but make sure they're parallel. You can, it's easier because they've said that it is drawn to scale. That means that you can measure this angle, right? And you can measure
Yeah.
this angle, right? So that way you can basically just, use this as your starting point, and then you can measure that, what this angle is. Okay, so make sure the angles are the same. So that means that, let's say if I take this my reference point, this is 30 degrees, okay? Then at this point, this should also be at 30 degrees. Okay.
Okay, but like, is it
Hmm.
okay if we have like if it becomes 31 instead of 30, or would that
That's
be
fine.
wrong?
That's fine. In scale diagrams, keep in mind that there will always a range of inaccuracy. Okay,
Okay.
that means you will get. In fact, the marking scheme will always show a range of answers that all these answers are acceptable. Always. In scale diagram method, it's by nature a little inaccurate. So that doesn't matter. Okay. So this was a 10
Okay.
centimeter line. This was 7 centimeter. Okay. And then you draw the same thing for the 10 centimeter line as well. You keep your angle, you keep your scale at the same angle, and then you draw it like this. Okay. And this is the 10 centimeter line again. Now what you do is, do you see that this has become a parallelogram? Yes, Anya, with me? Kaima, any questions so
Yes.
far? Yes, drawn it parallel to parallel, right? Okay. Now what you do is, now to find out the resultant force, right? That was the point of solving this question. Like, where is the resultant force? Is it over here? Is it over here? Is it over here? Where is it? Now what you do is, you take the tails, both tails are connected, and you see that both heads are connected. You're going to draw a diagonal line from the tails to the heads. And this is going to be your resultant force. So that means when you measure this force, you're going to measure this force, take your scale and measure it. This is going to be roughly 13 point, what is it? 13.3. 13.3. Huh. So this came out to be 13.3 newtons. 13.3 newtons means, sorry, 13.3 centimeter, which means that the resultant force is 13.3 centimeter. Now, if I want to figure out the direction, well, the direction is already drawn for you. You can take the angle at this point. I think it would make sense for the angle to be from the horizontal. So that means this is your horizontal. Okay, right? This is your horizontal value. Okay, right? This is like, perfectly, parallel or perfectly ground or perfectly horizontal. Then you take this angle, you measure out this angle by your protractor. I don't think so. I would be able to do it pretty well from my. So this is 170. So that must mean this should be 10 degrees. So that means that if you were to take the compass, okay, if you were to take the compass, this is north, this is south, this is west, and this was east, right? So do you see it's somewhere between east and south, right? In fact, it's more towards the east. So you could say that the resultant force is uh 13.3 newtons, 13.3 newtons, southeast with 10-degree angle from horizontal. So that's how you make your answer like extremely precise. This is you may have done, these scale diagrams in IGCSE, but this is one step up where you'll be asked to draw the angles, where you'll be asked to draw, what is the direction, and you've got to figure it out by yourself. So I've drawn one complete full example for you. Okay, so this is how you do it. So have I I'll write it down in steps as well. Any questions? Yes, Kaima, with me?
Yes.
Yes, okay. I've even recorded this lecture. You can, watch it afterwards. So number 3, but, make sure you're hearing very carefully. If you've got any questions, ask me, right away. Don't hesitate. Acha. So, number 3, draw both forces attached by tails. Okay, okay. And what was the next step? We've drawn, so draw the parallels, of both forces. Okay. Then what you do is you join the tails and heads by a diagonal line. By a diagonal line. Do you see that this is the diagonal value of a parallelogram, right? This is literally the diagonal value of a parallelogram that is pointing from this end to this end. So by a diagonal line, and the diagonal line, what you do is then you do the measurement of the diagonal line. Measure diagonal line, and then this is going to be my resultant force. The angle measurement will always depend upon the case. It will, it might be that you might have to measure from horizontal. It might be you might have to measure between north and east. You might have to measure from this, but always keep the compass in mind. The compass is a really good way to understand it, that, where do you get the angle? Like where does it make sense to figure the angle out? And in this is, this, I'm just making up the example, but in the exam, they will always tell you that figure out what this piece of angle is. So don't worry about that. Okay. So that means they'll already tell you that figure out what this angle is. You won't have to figure out where to figure out the angle. Okay. But this is just an example. They'll tell you where to measure the angle and you'll have to measure it by yourself, however you want. Okay. Okay. I think my line is crooked though. This is 0. This is not 0. So that means this is supposed to be like this. This is not perfectly parallel. This is. So that means this is going to be my horizontal value. And then this is going to be, this is 170. So that means this is actually 20 degrees. This is actually 20 degrees from east. So this is 20 degrees. Okay. Perfect. Beautiful. Yes, Ariz, does that make sense? The parallelogram method.
Yeah, it does.
Yes, Hania?
Sir, I don't get why we made the horizontal line. Like, what's the logic behind it?
The horizontal line's purpose is basically to figure out that where is this resultant force pointing. That's the entire purpose of it. That's all. I just made this imaginary line that, and isn't even a part of the calculation and stuff. This is just an imaginary horizontal line, that where is the resultant force pointing? Is it pointing more towards the east, or is it pointing more towards the south? By how much is it pointing more towards the south? So that's the point of the horizontal line, right? It's just a reference point. Is it pointing like 40-degree away from east? Is it pointing like 60-degree away from east, right? You could also take the south side as your reference angle. You could take it from this side as well. It's just to tell you that where exactly is the resultant force pointing, because angle is dependent upon the reference side. So in the exam, don't worry, they will provide you the reference line and they will tell you that figure out what this angle is, right? In the exact way that you did it over here, right? When you calculated this theta, you imagine that there would be a horizontal line over here, which is your reference point, right? And from that reference point, this is the theta that we're calculating. But in this case, we don't really have a existing horizontal line because our resultant force is pointing like downwards, in some weird way. So that's why we made up our own imaginary line, but that will be given to you in the exam. Okay. Hania, make sense?
Yeah, I got it.
Okay. Yes, Kaima, make sense?
Yes.
Yes. Okay. Are you sure? Parallelogram method. I've written the steps. Any problem in the steps?
Wait, so the angle of
Hmm.
the angle of direction for the resultant force would be 20?
Yes.
Okay, so it's based on the normal, not based on like the other.
So I specified, right? I specified the force is 13.3 Newton, southeast, right? Between south and between east. And I measured
Okay.
the 20-degree angle from the horizontal. Okay. So
Okay.
that's how I'm going to be like really, really precise. Okay. So this was the
So
scale
so
diagram
this
method.
so this like all the times you have to do it like this, right?
Now I'm going to get to the next part. This was the inaccurate method, right? Now we don't always really do it like this, because do you see, like, it took so much time to figure this stuff out, and it was like very hectic, and I had to make so many lines and I had to measure so many angles. And that's why we're going to move on to an advanced technique. You should be able to do this, right? Because they could, give a very, compulsory question on this. But most of the times in A-level physics, what we do is we skip this step and they want you to move on to a more advanced method, which is what we call vector resolution. That means that, for example, I have the same boat, okay? One person is pulling 8 newtons to the right. I've been given this angle, okay, from the horizontal. And I've been given another force that's pointing downwards at 10 newtons with a degree of 40 degree. And there's one other person that's, perfectly pulling to the left, which is 3 newtons. Now, how do I figure out the resultant force? I don't know, right? I can't, because these 8 Newton and 10 Newtons do not have the same angle as 3 Newton, right? Because this 8 Newton is pointing towards this side, this 10 Newton is pointing toward this side. I can't really add them directly at all. If it were like 8 Newton to the right and 10 Newton to the right, then I could have just done 8 plus 10 and then minus 3. But that's not the case. Now, how do you do this example? Now we're going to move on to the next advanced technique, which is what we call vector resolution. Okay. Vector, really extremely important. This is what we call vector resolution. But what we're going to do is we're going to break the vector apart into components. I'm sure, in your classes, you must have gone through this and it might have completely skipped over whatever the hell this is. Any ideas what this is? Breaking vectors into components. Yes, Anya. I remember you telling me that you didn't really understand it at all in your classes. Did you?
Yeah, I still don't know what it is.
Okay. What about you, Kaima? Have you covered that at your school? Vector composition and vector resolution.
Yes.
Yes. Any idea what it is really?
No, I didn't really get it.
I don't know. What about you, Ariz? Did you get it? Or are you also confused about that?
I mean, like, I kind of understood it a little bit, but then it just,
Okay.
after looking at the past paper questions, it skipped over
Okay.
my head.
Perfect. Makes sense. Okay. Prepare for your mind to be blown. So, what vector is? This is a force which is a vector, right? Now, you see that this force is at an angle, right? Which is 45 degrees. Do you see that it's neither upwards, it's neither up, neither right, right? The force isn't really going upwards and it's neither really going to the right. It's somewhere in between. So can we say that this 7 Newton force at 45 degree is actually equal to a little bit force to the right and a little bit force to the upwards, right? Because it's a combination of both. It's going a little bit to the right as well. It's going a little bit to the up as well. So you could say that there's a certain amount that is to the rightwards, okay? Rightward force plus upward force. With me so far? Yes, I want you to be responsive now. It's neither up, neither to the right. It's a combination of both, right? So the angled force is actually a combination. It's a combination of both right and up. Yes, R is with me. Make sense?
Yeah, till now,
Okay.
yeah.
Yes. Okay. So how about, can I figure out how much is right and how much is left or how much is up? The main question is how much of the force, is up, okay? And how much of force is right, okay? So let's bring this vector down. Anya with me, Kaima?
Yes.
Yes, okay. The question is, we know that this is, slightly to the right, slightly up, but how much? How much is it to the right and how much is it to the left? Okay. That means you could say that, someone is pulling at an angle of 7 newtons. There is a little bit of rightward force, right? There is a little bit of rightward force and there is a little bit of upward force. They're both combining to make this resultant 7 Newton force. This is the effective force at the angle. But how do I find out what is the contribution, right? Like how much is pointing to the right and how much is pointing to the upward, right? Can I break this vector into two components? Because I know that two components towards the right and towards the up are making this vector. Now, how do I break it apart? So if you have this triangle, okay, Let's break it into a triangle. Let's see. 7 Newton was upwards. Okay. Now, can we say that this force is the force that is towards the right? Let's call it F horizontal. Can I do that? Can I call the rightward force as F horizontal? This is like only the horizontal part of the force. With me so far? Yes, Hania?
Yes.
And can I say that this line, which is pointing upwards, is the vertical part of the force?
Yeah.
Yes? Okay. Now, what if, since this is a vector, can I bring this over here? Can I bring this line over here? Because they're parallel vectors. They should be exactly the same, right? I just I just took this and I brought it over here. Nothing else. It's literally the same thing, because vectors, parallel vectors are literally the same. You can move them around like this, but if their length is the same, then that means you effectively did nothing. Yes, with me again or no? We do the vertical force, and then I simply brought it over here. That's it. That's all I did. Okay. Now, this was the vertical force. 1 second. This was the vertical force, and I've already drawn the horizontal force. Okay. So that means this force is basically the vertical part of the force. Okay. And this force is the horizontal part of the force. That means both of these components are going to combine and then result into this 7 Newton force effectively. Okay. 1 second. Okay. Huh. So yes, guys, with me? Ariz, all I did so far.
Yeah, I understand it.
Okay. Hania, Kaima, yes,
Yes.
got it so far. Okay. I just broke the vector into two components, the horizontal component and vertical component, because any vector is basically, it's you can break it into its vertical and horizontal component. This is the horizontal component and this is the vertical component. You can draw them either ways. You can draw this like this or like this. They are both the same thing. I'll in fact draw it out. This is equivalent to this. You literally just took it around like this. Okay. Now, how about if I want to find out the vertical part of the force? Let's see. Let's have a recap to trigonometry. Let's call this as the perpendicular. This is the hypotenuse and this is the base, right? And let's call this as theta, because opposite to this is the perpendicular. So let's see, for example, let's instead of uh, h hypotenuse, let's write f. Okay. Now, how can I find out this p value? How do I find out this perpendicular value? By using sine theta. Can I use sine theta? Yes. Sine theta is basically just equal to perpendicular over hypotenuse, right? I'm talking about the vertical part. So vertical part at the moment. I'm talking about this line, P. I want to find out the value of P. Now, if I want to find out the value of P, isn't P just going to equal to H times sine theta, where H was the hypotenuse? H was hypotenuse. And isn't in this example H equal to F? So that means, 1 second. So that means that this vertical component or this, vertical side is just going to be P is equals to F sine theta, right? So wasn't this basically your vertical component? Wasn't this basically your vertical force? F vertical. And instead of perpendicular, can I just write F vertical is equals to F sine theta, where F is the hypotenuse, right? Let's do the same thing for the horizontal triangle. Okay, we're just getting to it in just a second. Again, you draw a triangle. I know that this is equals to F, right? This is the value of F, the absolute value of F at an angle. And I know that this has been labeled as F vertical and this has been labeled as F horizontal, right? That's the horizontal part of the force and that's the vertical part of the force. Now, how do I find out horizontal force? Isn't this basically equal to your base, right? And can I use cos theta, which is equals to base over hypotenuse? And if I want to find out the base, isn't that basically hypotenuse multiplied by cos theta? That means, what is the base? Base is basically another name, what I just called F horizontal. So that means F horizontal is basically equal to F, which is the hypotenuse times cos theta. Now, this is a very, very extremely important statement that the vertical part of the force is basically equal to F sine theta and the horizontal part of the force is F cos theta. So this is like really, really important. Now, if you take this, I have figured out from this like small derivation that the horizontal part of the force is always F times cos theta and the vertical part of the force is always F sine theta. So that means if I want to figure out what is the vertical force by just looking at this example, I can say that the vertical component of this force or the vertical part of this force is basically just F sine 45. And if someone asks me what is the horizontal force, that is just going to be 7 cos 45. Why? Because I figured it out over here that for any vector, okay, any vector, I draw it at any angle, okay. I draw, let's say, I don't know, let's call this A, okay. Let's call this vector A. And I know that this has an angle of, let's say, angle of, I don't know, theta. Let's just call it theta. Let's keep it simple. Now, this vector has a composition of both somewhat vertical and somewhat horizontal parts. This is going to be my horizontal part. Let's call this AH. And I know that this is going to be my A vertical. Now, if someone asks me what is the vertical part of the area or, whatever that vector is, that's just going to be A sine theta. And what is the horizontal part? That's just going to be A cos theta. So that means if you're talking about the horizontal component, it's always A cos theta. If you're talking about the vertical component, it's always sine theta. An easy way to remember it is angle in front of the angle, it's always sine. Angle in front of angle, it's always sine. Okay. With angle, it's always cos. So that's how you figure out vectors. Did any of it make sense? Yes. Ariz? Or no? Or too much maths?
I mean, yeah, but could you also like show the
Hmm.
other method as well using the scale diagram?
So basically, we're not using the scale diagram in this method, and we can't because you know what we're doing. Do you see that, for example, I broke this force into two parts, the vertical part and the horizontal part. Okay. This basically means that imagine that there was one guy that was pulling upwards with a force of 7 sine 45. And there was another guy that was pulling to the right by a force of 7 cos 45. Now, where is the resultant going to be? Do you remember what we took was we took this force and we took this force and we joined them head to tail, right? And then we joined the tails to the heads. right? Wasn't this equal to the resultant force? So that means if I want to find out the resultant force for this method, isn't that going to be 7 sine 45 square plus 7 cos 45 square, and then you take an under root? I guarantee you the answer is going to be 7 Newton. Because what we did right now is the opposite of the resultant force, right? In this example, what we were doing is we were trying to find the resultant force, okay? By using the components, right? Someone was pulling up and someone was pulling to the right. But in this part, in vector composition resolution or vector resolution, we are seeing what are the components that made this 7 Newton force. I'll write that down. What we are trying to figure out is what components made up this force. Do you get what I'm trying to get at, Aris?
Okay.
Or-
Yeah.
Okay.
Yeah.
So the previous thing that we were doing was we were just seeing that if been given a horizontal force and a vertical force, how do you combine them and how do you find out the resultant? Now what we're doing in this example is we are finding out that if this is my resultant, okay, at a certain angle, what forces would have made up the 7 Newton force? Okay. Take a few minutes to have a look at this. I'll be right back. And be prepared with questions, as in, I want questions from. Okay. Yes, Kaima, did you get what we did?
Yes.
Okay. Hania, do you have a better understanding now of how to break components and how to
Yeah.
resolve components? Yes. In fact, you can just do it straight away now. For example, I give you a random force, or it could be with any vector, by the way. Let's say velocity. Velocity is 5 meters per second at an angle, okay? But the angle is, let's say, 30, okay? Now, 5 meters per second at 30-degree angle, that means it's a combination. It is going both right, it is going both up and both right, right? This part of the vector is going to be how much is the ball going toward the right, right? And the upward vector is going to be how much is going to be the vertical velocity. So we'll call this the v vertical, right? How much is the ball going up? And the yellow part is going to be v horizontal. How much is the ball going right, right? Because when I throw something at an angle, it's going both towards the right and it's going both up. It's a combination of both of them. Now, how do I find out the vertical velocity of the ball? I simply use I'm going to use v sine theta for this part. Okay. Why? Because I figured it out that, always the vertical part of the force or whatever the vertical part of that vector is, it's always going to be hypotenuse multiplied by sine theta. So that means it's just going to be 5 sine 30. Okay. And this is just going to be v cos theta, right? Which is going to be 5 cos 30. Let's see. Let's see what that number turns out to. Does anyone have a calculator and check quickly what that turns out to? 5 cos 30 and 5 sin 30. 5 cos 30. This is 4.33. And 5 sin 30 is 2.5. That means that if the ball was going by 5 meters per second at a 40-degree angle, okay, what was its vertical velocity? The vertical velocity was 2.5 meters per second, okay? And what was its horizontal velocity? How quickly was it covering like horizontal distance? That was 4.33 meters per second, okay? So you've basically figured out what vectors were basically making up this 5 meters per second, okay? Yes, RS, got it?
Yeah.
Yes, okay, perfect, brilliant. Yes, guys, have you better understood the resolution of forces? It's pretty easy. It's just taught wrong. Yes, Anya.
Yeah, I got it. Also, in the actual past paper questions, do they just
Hmm.
directly ask us like the vertical force and
Ah,
like the
they
horizontal?
could, yes. I've just given you the basics for vector composition, okay? In the next class, what we're going to do is we're going to use this method to break vectors into components and then apply them to problems. For example, this question, we'll have different forces at different angles, and then we'll be asked to find out the resultant. Then you'll have this question. For example, this question, right? There's someone pulling at an angle of 50 degree at 30 degree, right? And there's someone pulling 40 at this side, and there's someone pulling 30 downwards. And for example, this boat example, right? You've got this 8 Newton force at 35, and you've got this 10 Newton force at 40. How can we break this angled force into its components? Can we break it apart into its horizontal and vertical parts? We absolutely can, and that's what we'll be doing in the next class. Okay, so the past paper will not always ask you, like what is the component of this vector. They can ask you, but most of the time they will ask you the application of it. Okay, I do have a few questions over here. For example, this question. For example, this is a question where they say a force of 7.5 Newton acts at 40 degree to the horizontal. So it's 40 degree from this point. They're asking you calculate the component of the force that acts horizontally. They're basically asking you what is the horizontal portion of the force. Now we know that the horizontal is actually this one. This is just going to be F sine 30, sine 40, right? Whatever this F is. In this case, this is F. And what is the vertical part of the force? That is going to be F cos 40. So that means the horizontal part, sorry, that's opposite. This is going to be sine. This is going to be cos, because with the angle it's cos, and in front of the angle it's sine. And keep in mind, I could draw F sine 40 over here, or I could draw it over here. They both basically mean the same thing because they're parallel vectors. Okay, so if I want to find out the horizontal component, I just do F cos 40, which is what? Which is just 7.5 cos 40. And what is the vertical component? That's just 7.5 sine 40. Okay, so that's how you plug in your answers. And then what they do is, then they give you an application that you want to resolve this question into forces, into its component, then find out the resultant force. It's a 4-mark question. So we'll be doing this question as well pretty soon. Okay, perfect, great. Yes, Ariz, had fun?
Yeah.
Yeah, okay. Kaima, satisfied with the explanation?
It's just that
Yes.
question which you showed,
Okay.
the 4-mark past paper question which you showed, those are the questions which I'm struggling with. I mean, like our teacher
We'll do
showed it in class and I wasn't able to do them.
this exact question.
Mm, I think she showed a similar question to this, not the
Okay,
exact
that's
one.
fine. Don't worry.
Maybe
Don't worry.
sort of answer.
We've done the concept. You've got the basics, and now after, before the next class, I want you to review everything we've done so far, write it down, make notes, try to see whether you've understood it. If you have any questions, let me know in the next class. And in the next class, we'll be doing the application of this methodology. Okay?
All right.
Perfect. I have recorded this lecture as well. I'll send it to you if you want to watch it again. And that'll be all. Take care, guys. Hope you had fun.
You too, sir. Bye.
Okay.